The objective of this lesson is to solve fraction subtraction problems with regrouping by replacing one or more fractions with an equivalent fraction. In previous lessons, students have subtracted mixed numbers with unlike denominators, where the subtrahend fractional piece was smaller than the minuend fractional piece. Students have used the strategy of regrouping with whole numbers as well as decimals. Today, students will extend their knowledge of regrouping with mixed numbers. Let's begin with our first problem. Michaela has to drive 5 3/8 miles to the studio where she has dance class. She stops after driving 2 7/8 miles to pick up her friend Hadley. How much farther does Michaela need to drive to get to dance class? The equation to represent this problem would be 5 3/8 miles she has to drive minus the 2 7/8 miles she has already driven equals d, the distance left to go. Model this by drawing a long rectangle and partition it into 6 sections. Shade in 5 whole sections to represent the 5 miles. The last unshaded section will represent the fractional portion of her total miles to drive, 3/8. Divide the last section into 8s and shade in 3 parts. Start by subtracting the 2 whole miles. This is done by crossing out 2 whole sections. The next step will be to subtract the fractional part of the 7/8. There are only 3/8 to subtract from. In order to subtract the rest of the 7/8, one whole will need to be partitioned into 8s. Now there are 11/8, which is enough to take 7/8 away. Cross out 7 of the 8 sections. The shaded portion that is not crossed out represents the difference, or the miles Michaela still has to drive. She still has to drive 2 4/8 miles. Now let's solve the same problem numerically. 5 3/8 miles minus 2 7/8 miles. Let's start by subtracting the fractional pieces first. 3/8 minus 7/8. 7/8 is a larger amount than 3/8. In order to solve, the 5 must be regrouped. It will be regrouped into 4 wholes and 8/8. The new expression will now read 4 8/8 plus 3/8 minus 2 7/8. Let's combine the regrouped 8/8 with the 3/8 for the initial starting miles. This will be a total of 11/8. The expression is now 4 11/8 minus 2 7/8. Now the minuend has enough 8s to subtract 7/8. 11/8 minus 7/8 is 4/8. 4 minus 2 is 2. There is still 2 4/8 miles left to travel. Let's solve one more problem. Brody needs to fix the chain on his bike. He bought a piece of chain that is 3 1/3 feet long. After measuring, he determines that he will only need 1 1/2 feet of chain. How much chain will he have left over? The equation to represent this problem would be the 3 1/3 feet amount of chain he has minus the 1 1/2 feet he needs equals the amount left over, A. Let's draw a model. Start with a long rectangle. Divide the rectangle into 4 equal sections. Each section represents one whole. Shade in 3 holes. Then divide the last piece into thirds and shade in 1 piece to represent the 1/3 portion of our beginning chain length. The equation states to subtract 1 1/2 feet. The fractional parts, 1/3 and 1/2, do not have common denominators. Multiply the denominators together. 3 times 2 equals 6. The common denominator is 6. Multiply the 1/3 by 2 and the 1/2 by 3. The equivalent equation reads 3 2 6 minus 1 3 6 equals A. On the model, this is shown by taking each 1 1/3 piece and turning it into 2 pieces. The thirds become 6. 1/3 is equivalent to 2/6. Looking at just the fractional part of the equation, it states to take 3/6 away from 2/6. There are not enough 6. In order to take the 3/6 away, one whole section must be partitioned into 6. This whole becomes 6/6. There are now 6/6 plus 2/6 for a total of 8/6. The new equivalent equation reads 2 8/6 minus 1 and 3/6 equals A. 8/6 minus 3/6 equals 5/6. This is shown on the model by crossing out 3 of the 6th. 2 wholes minus 1 whole is 1 whole. Cross out 1 whole section on the model. There is 1 and 5/6 feet chain left. The objective for this lesson was to solve fraction subtraction problems with regrouping by replacing one or more fractions with an equivalent fraction. We met this objective by using models as well as the common denominator strategy to generate equivalent fractions with common denominators. We also decomposed mixed numbers into fractional parts and wholes, and regrouped some of the wholes into fractional pieces in order to subtract.